Here's number 3 from the test review. It asks, you can look at the test review posted online to see the problem statement. It asks you to find the area in a region bounded by these two curves, y equals x minus 1 and y squared equals 2x plus 6. So on test number 1, I do plan to provide a picture of the graphs of the functions. So I would give you the two curves here, and you should be able to recognize that between the curves is the area that's shaded in like I'm doing now. It's completely bounded by the two curves. They make the whole boundary of it. Okay, so that leads you to the first step, which is also the first step of finding a volume of rotation, which is to decide whether you're looking at a type 1 or a type 2. All right, so this one is type 2. By process of elimination, if you try to make it a type 1 and slice it up into vertical strips, you'll notice that sometimes you would have the curve parabola on top and the straight line on bottom, but when you get all the way over to the left hand side, you have a parabola on top and on bottom, and that's the trouble. And what you need is for the same curve to always be on top, the same curve to always be on bottom to be a type 1, or to be type 2, the same curve always on the left, same curve always on the right. And that works out great. For type 2, you can make these horizontal slices, color them in a little more, and no matter where you make them, at the top, in the middle, you always see the parabola, the curve on the left, and the straight line on the right. So we want type 2, and that immediately lets you know that we're going to be working with the y. We could call it type y, but that means that we have dy as the last thing we write down in our integral, and it means that we're going to be using y1 to y2 as the limits of integration, the lower and upper points of our integral. And we're also going to need functions of y. We're going to have to solve those functions, those curves for x. So that we get x equals f of y. When you solve for x, you get x equals f of y, and that'll give you functions of y to plug into the integral. So might as well go ahead and do that for both of these givens. The first one's easy, solving for x there. I get x equals y plus 1. Add the 1 to both sides. And the second one there, let's see, I'll probably want to subtract the 6 from both sides. And then divide everything by 2. So I could write it the other way. If I divide everything by 2, I'll get x by itself. And I'll have 1/2 y squared minus 3. And just as an aside, that's how I actually went about graphing this. You're going to have the graph provided for you, the picture of the curves. But 1/2 y squared is a parabola on its side, laying opening to the right. And minus 3 means that it's shifted over to negative 3. And y equals x minus 1, actually it's easier to remember how to graph that, is a straight line shifted down to the y-intercept of negative 1. So they make sense. And now I need y1 and y2, so I need the lowest y value and the highest y value. Alright, so I've marked them on here already, but you won't know that. You'll need to figure them out. And to do that, we need to figure out where those curves cross. So I'll set I need y values, so I'll set y plus 1 equal to 1/2 y squared minus 3. And those are the setting the x's equal to each other. The x is equal to x, so y plus 1 equals 1 half y squared minus 3. Solving that will give me those two y values. I might need the quadratic formula, or I might be able to factor it. Let's see. First, I think I'll go ahead and multiply through by 2 to get rid of the 1 half. Their fractions are always harder to work with, right? So 2y plus 2 equals y squared minus 6. Now move everything to one side. I'll take that y squared side, and I'll subtract the 2, so I'll have y squared minus 8, and I'll subtract the 2y, so I'll have y squared minus 2y minus 8 all equal to 0. And again, I wrote it in the other order, equal signs. You can always write things either way you want to. So I did minus 2 on both sides to get y squared minus 8 and minus 2y as well. And that does factor out. You can turn it into, let's see, something that makes 8 4 times 2. One of them should be a negative to get a negative 8. And that'll be the 4. So I have a minus 2 there. So I'll do y minus 4, y plus 2, 0. And then I see y equals 4 and y equals negative 2. That's the answer to that equation, and I mark that on the graph. That's the lowest, the y value of the lowest point and the highest point. So the area then is ready to go. Negative 2 over 4. And now what I put inside the area integral is the area of one of those slices that from negative 2 up to 4, I'm drawing slices that go from left to right. So I always have to, well, first I always have to make sure I put the smaller or the lesser value at the bottom of the integral, big value on top. And then I always have to make sure I do subtraction of bigger minus smaller inside. So if I look at this, the bigger is the one on the right, and that's that straight line. So it'll be y plus 1 minus, and then the lesser is the one on the left. That's the curve. That's the 1 half y squared minus 3. Dy. You can leave it like that, or put another parenthesis. It's really kind of okay either way. You definitely need the parentheses after that minus sign. If you don't parenthesize that part, then it will turn out to not distribute the minus and will mess up the answer. So anyway, that's the setup. A lot of times on these problems, I'll say, just give me the setup, don't work it out, and you'd be finished right there. And all the pieces of that are worth a little bit of the points. And if you want to actually find the value, now you have to just simplify and anti-differentiate. We've got y plus 1 minus half y squared, and then minus minus 3, so it'll turn into plus 4. Y plus 4 minus half y squared. Raise and divide those. Gives me y squared 2 plus 4y minus y cubed. And dividing by the 3, I'll get them divided by 6 there. There's already a 2 underneath. And from negative 2 to 4. So that's just arithmetic now. Plug in the 4 and get 16 over 2 is 8 plus 16. The 4 goes into there, and it gives you 64 over 6. And now plugging in the negative 2, I get 4 over 2, which is 2. I get minus 8. And I get a double negative because 8 over 6, but negative 2 goes in, there's a negative, so plus 8 over 6. Now, this is the part that you have to be extra careful on. And one of the reasons why I like to just have you answer by giving me the setup. All this arithmetic is really only somewhat valuable. It'll be worth a point if I give that part to you, and I'll look at the setup for most of the credit. Let's see, but we do end up with 8 plus another 8 plus another 16, so we get 32 out of that. Minus 2 is 30. Then from the fractions, I have a minus 64 and a minus 8, so that gives me minus 72, or 72 divided by 6, so a minus 12, so I get a 30 minus 12, which comes out to 18. All right.